This is a deeper exploration of Kepler binary planet systems and their comparison with the wide binary architecture of Zeta Reticuli. We begin with Kepler 16. The two stars orbit each other every 41 days at a separation of 0.225 AU. The primary is a K-dwarf of about 0.69 solar masses. The secondary is an M-dwarf of 0.20 solar masses. Their circumbinary planet, Kepler 16b, is a Saturn mass world of 0.33 Jupiter masses and 0.75 Jupiter radii. It orbits the barycenter every 229 days at 0.705 AU, with an almost perfectly circular eccentricity of 0.007. The equilibrium temperature is roughly 188 Kelvin, a cold gas giant. Light curve behavior is distinctive. The binary produces deep primary and secondary eclipses. The planet transits both stars at irregular intervals because the stars are moving. Transit timing and duration vary, creating a complex photometric signature that confirm the circumbinary nature. Next, Kepler 47. The binary itself has a period of only 7.45 days. Three planets are known. The inner planet, B, orbits every 49 days at 0.29 AU. The middle planet, D, every 187 days. The outer planet, C, every 303 days at approximately 0.96 to 0.99 AU. Planet C sits in the conservative habitable zone. Its time-averaged insolation is about 0.87 times Earth's, with modest variation caused by the moving stars. Equilibrium temperature estimates near 241 Kelvin allow the possibility of liquid water under suitable atmospheric conditions. Habitability modeling for circumbinary systems must account for rapidly changing stellar illumination, dual tidal forces, and the dynamical stability limit. Planets must remain outside roughly 2 to 4 times the binary separation to avoid ejection. Now the comparison with Zeta Reticuli. Zeta Reticuli is a far wider binary. The two solar analog stars are separated by at least 3,750 AU, more than 16,000 times the separation of the Kepler 16 binary. Their orbital period exceeds 170,000 years. At such distances, the two stars exert almost no mutual dynamical influence on any planets that might orbit one or the other star individually. Circumbinary planets of the Kepler type would be impossible. The gravitational environment is essentially two nearly independent single-star systems. In Kepler systems, the short binary periods create strong, time-varying gravitational and radiative forcing. In Zeta Reticuli, the forcing is negligible on human or even geological timescales. For a hypothetical non-human intelligence, a Kepler-style close binary would produce a highly dynamic natal chart with rapidly shifting aspects relative to two luminaries. A Zeta Reticuli-style wide binary would produce two nearly independent charts that evolve only over tens of thousands of years. These real architectures give concrete anchors for alien astrology and quantum astrology. Close binaries demand charts calculated from the barycenter with strong dual influences. Wide binaries like Zeta Reticuli allow more classical single-star techniques applied separately to each component. The stars teach us scale. From 41-day orbits to 170,000-year orbits, the universe offers every possible configuration for life and for consciousness.